first part of this problem asks about the gas's change in internal energy. Now recall that internal energy is related to temperature. So the internal energy of a gas, as long as the gas is ideal and monatomic, for example, is equal to 3/2 multiplied by the number of moles multiplied by the constant R multiplied by the temperature. Now in the case of this problem, we're told that the gas is expanding isothermally, which means that the temperature is not changing. So if the temperature isn't changing, and we assume the amount of gas is constant, then U, the internal energy, that's not changing either. So when the problem asks for the change in internal energy of the gas, we have to assume that the change in the internal energy is equal to 0. It is not changing at all because the temperature doesn't change. Now part B of the problem asks about the heat absorbed during the expansion. This part of the problem is where it's a good idea to apply Newton's first law. Or not Newton's first law, but the first law of thermodynamics. And the first law of thermodynamics states that the change in internal energy is equal to heat, that's the heat added to the system, minus W, the net work done by the system. Since this problem is asking for the heat absorbed, then we're looking to solve for Q. And reminder that delta U is equal to 0, as we established in part A. So algebraically solving this equation for Q, we can see that Q is just equal to W. So the heat absorbed by the system is the same as the work done by the system, which is just given in the problem as 4.30 times 10 to the power of 3 joules. So that is our answer for part B. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos like this. And if you have a request or a question, leave a comment down below, and I'll do my best to help you out as best as I can. That's all for now, and I hope you have a lovely day. Bye-bye.